When you train a neural network, we usually split our dataset into 3 different disjoint parts. And nowadays, we usually have a huge dataset, so we have enough data to train and validation and test. And most of data point will be used to train your neural network. So this huge part will be training data set, and the small 2 portion will be for validation and test. Okay, and when you train your neural network, so we usually plot 2 different training curve. So here the x-axis represent the epoch, number of epoch, and you plot the training error curve and some validation error curve. Okay, and from the training error curve and validation error curve, you will control your hyperparameter. There are a lot of hyperparameter, the width of your neural network, so each layer's number of activation unit, and layers, which also some important hyperparameter, and learning rate, and so there are a lot of hyperparameter, and we have to control these hyperparameters so that our validation error can be minimized or decreased. Okay, so essentially when you have some target performance, based on this target performance, we have to control your hyperparameter. So let's consider this first example. When you train your neural network and you have this situation, your training error is bigger than some target error. In this case, the training itself is not good, right? So we have to improve our training performance. So to improve the training performance, we usually can consider 2 directions. The first one is the increase the width of your neural network. And the second consideration will be the increase of layers. The number of neurons you increase, or you can increase the number of layers. Both are fine. With both approach, you can expect some decrease of training error curve. So as you increase the width, so when you increase the number of neurons of each layer, you can expect some monotonically decreasing of your training error curve. Right. And for this case as well. But usually when you increase the number of layers rather than the number of widths, your training error curve sometimes some wiggly. There is some kind of up and down, and even in some cases there is some increasing part as well. Okay, so with increasing layers, sometimes we cannot expect the better training error curve. I will explain why such thing can be happen in the next video, but remember that increasing width is more easily decrease the training error. So if you really want to decrease the training error, the most convenient way is increasing the neurons per each layer. But remember that when you increase the width, your number of parameters increase very rapidly. Okay, so usually the number of parameter is proportional to the width scale. So the number of parameters increase very rapidly as you increase the number of neurons per each layer. But on the other hand, if you increase the number of layers, the number of parameters just increase linearly. So from this property, usually when you increase the width, the overfitting issue becomes more severe, crucial to train your neural network. And in general, when you increase the number of layers, the overfitting issue does not appear in many cases, right? So you have to keep in mind, you can decrease the training error very easily by increasing the width, but usually increasing width can incur some overfitting issue, right? So that's why many modern neural network architecture, they are trying to increase the width while keeping the same number of parameters by um, um, splitting the weight matrix. So usually they try to introduce some product form of weight matrix so that they can decrease the number of parameters while keeping the width. Then because we use much less parameter than before, we can solve some overfitting issue due to the wide neural network structure. Okay, all right. And when your training error is better than your target, but if the validation error is much bigger than target because of overfitting issue, then we have to decrease the validation minus training error value by using some technique. There are many possible approaches to reduce the overfitting. And we will discuss this thing in the next video clip.